Hi, it's David Teedy again. This time I'd like to give you a little video tutorial on using the equation editor in Microsoft Word. You probably had some experience using the equation editor in mastering physics so far. I think the equation editor in Microsoft Word is better and more capable, and it'll be useful to you to learn how to use this, perhaps for writing your lab reports, or just generally corresponding with me if you want to talk about equations or whatever in your future. So I'm going to start by entering some equations that we're currently studying, the equations of motion in one direction. We have the one where the velocity is equal to initial velocity plus acceleration times time, where the acceleration is a constant. Another one where the position as a function of time is equal to its initial position plus the velocity times the time, plus, if there's constant acceleration, half the acceleration times time squared. The usual constant acceleration we experience in this course is the acceleration of gravity, which is abbreviated g and has a value 9.8 meters per second squared and directed towards the center of the Earth. So if this, instead of x, meaning horizontal, were y, and y was positive, in the positive direction, then this acceleration would be a minus g, indicating the acceleration is downward. Another kind of a special equation, v squared equals v0 squared plus 2a times the difference between position and the final position and initial position, which has no time in it, is useful sometimes. And another definition of the average velocity is sum of a given velocity, initial velocity, the average over the time period. Let's use the equation editor to see if we can't duplicate some of these equations, and you'll see how it works. So I'll create a new line. The way you do it is insert an equation. It puts a type equation here bar in there, and you can just start typing. Let's do this. V equals V0 plus AT. So we'll say V equals. It automatically does a lot of the spacing for you. But now we've got our first, what do we do here? V sub 0. That's what this script tab is for. And you can have all kinds of scripts. You'll have something with a superscript, or something with a subscript, or something with both super and subs, etc. And have some examples of what you can create doing this. So what we want is a variable with a subscript. It'd be this one. And it creates a little text boxes for you to put things in. So we put the V here and a Z0 there. And now we have a V0. If you keep typing, it'll just keep adding stuff to the 0, but if you click just to the outside of that, it'll be ready for something new. You just type plus and then AT and return. We've created our first equation using the equation editor. The next one's a little bit more complicated, but not much. Let's try that one. Insert equation x equals script x 0. Click just outside of that. Plus, now we need the V0. We need a script again with subscript. V0. Click outside that so we can multiply it times the time. And then plus. Now, here we've got something new. 1/2. What do we do with that? That's what this fraction tab is for. Have all kinds of ways of expressing that fraction. Numerator over denominator with the slash, all in the same line, lots of different things. And some reasons why you might use it. Some of these are, deltas or differentials, dividing pi by 2 or whatever. So we're going to do this one here. And what we needed was, for this equation, a 1/2. So you put 1 here, 2 there, and click just outside of that so we can move on. A. Now we need a t squared, so that'll be something with a superscript. T squared. And we're all done. And we can move on to our next equation. I don't think you'd learn anything new if you watched me. Well, I guess you would, because here's a v0 squared. Let's try this one then. We'll insert an equation, and it starts off with v squared, so it's going to be with the superscript v. Whoops, I didn't get inside the box. Let's backspace that out. Click the box, v squared, just outside that, equals. V0 squared. So now we're going to have script again. This time we're going to have a v sub 0 and squared. So it's super and subscripts v 0 squared. Click outside to move on. Plus 2a. Now here's something new. You can type a left parenthesis, and that would start this, and then the x, and the minus, and then the x subscript 0, and then with a closing parenthesis. But there's also tools for making parentheses, especially if you're going to get more complicated or want to use different symbols, or curly brackets or combinations of things. Let's just try this one and see how that works. Created the parentheses already. So inside there we just need the x minus, and we need something with a subscript, x sub 0. Okay. So we've just created with the Microsoft Word Editor all the equations of motion in one dimension, and you could do the same. And you could practice doing that to learn a little bit how this works. Before I move on to the next idea, I want to talk a little bit about these equations. Notice that x as a function of time is quadratic in time, so it's t squared, t, and so on. So that means that if you were to solve this equation for t, for given values of x, x0, v0, and a, there would be two solutions. And we'll use the quadratic equation. I'm going to give you as an extra credit assignment to solve this equation for t using the quadratic equation. And if you do that and email me your answer constructed in Microsoft Word Equation Editor, I'll add an extra point to, I guess, the chapter on motion in one dimension. So let's talk now a little bit about what the quadratic equation is and how it's solved. I'm going to insert them first so we can see how to go about it. So here we go. Let's see if it formats it properly. There we go. So this is the general equation of a second order equation. Some constant, some numerical value times x squared plus some constant times x plus c equals 0. The whole idea is get everything on the left-hand side of the equation and leave a 0 on the right hand. And then whatever happens to be multiplied by x squared is the value for a. Whatever happens to be multiplied times x is b. And all the constant terms added together would be c. And once you know a, b, and c, the general solution for this equation is x equals. It's a ratio of minus b plus or minus the square root of b squared minus 4ac over 2a. This is a pretty important equation, and there's examples of problems that work this in your homework. By the way, there's also appendices in the back of the text that go over a lot of mathematical things, including the quadratic equation. Might be worth reading that as well. Notice again, I mentioned before that the quadratic equation has two solutions, and that's represented by the plus or minus sign here. So one of the solutions you take the plus sign, and the other solution you take the minus sign. Let's take a look at some special equations for this, special conditions for this equation. Let's suppose for the moment that c were 0. Then you'd have an equation of ax squared plus bx equals 0. And you'd have a factor of x you could take out, and you'd have ax plus b equals 0. So one of the possible solutions would be x would be 0. Let's see what happens now if we put c equals to 0. Okay, if c is equal to 0 here, then this term is 0. And the square root of b would be b, and so the answer would involve a minus b plus or minus b. So if it's minus b plus b, that gives the 0. So one of the solutions would be x equals 0. The other solution would be the opposite one. You'd have minus b, so you'd have minus 2b over a, or just minus b over a. Is that true? Yes. If c was 0, and you divide out one of the x's, and you'd have x equals minus b over a, as you can see just by solving it straight algebra. So all that works. Let's suppose that a were 0. What would happen then? Oh my gosh. In that case, it's no longer a quadratic equation. It's just bx plus c equals 0, in which case x equals minus c over b. Let's take a look at this equation. If a were 0, that term would go away as well, and the numerator stays okay, but the denominator turns into 0, and you can't divide by 0, so you can't use this solution for a quadratic equation if a is 0, because it's not a quadratic equation. Okay, let me state in words what I want you to do for extra credit. Let's rearrange this equation up here, the x equals x0, etc., in the form of the equation of a quadratic formula. Okay, I don't quite have it constructed here, but I'll copy in part of it. And make this equation editor equals 0. Okay, what have I done here? I've taken this equation and rearranged it in order of the quadratic term first, right here, then the linear term there, and then I subtracted x from both sides, so I'd have x0 minus x for the constant term, and since I subtract from both sides, the other side would be 0. So now this equation is the equation of motion for the x-axis as a function of time. And it's the same form as the general quadratic equation. Keep in mind, though, that this a is a constant, and this a down here is an acceleration, so these aren't the same values, don't have the same meanings here. But you now could write an equation for t as a function of this constant here, 1/2 a, and this constant here, which was b for b0, and this constant here, which is x0 minus x, which is c. And you have a general solution for the time at which that equation is true. It turns out you'll have a fair number of questions in your mastering physics assignments for which you'll need to know exactly this time. I like to solve problems like this in general, and then I have the equation, and then all I have to do is plug the numbers in, and I'll get the answers, and I've already figured out the physics and the algebra first. So your assignment is to now solve this equation. Give me an equation for t, like this form here, involving all these variables in the equation editor, and email me that equation, and I'll add an extra point, extra credit point to your kinematics in one dimension assignment. I'll create another video to talk about some more, so these videos aren't quite so long, and let's see how you do with this one.